Now we need to add a multiple of 10, so a number that ends in a 0, to a 4-digit number. And we can do that using what we know about place value, so without using column addition. First, we have 8,054 plus 50. So if we highlight our tens digits, we have 5 plus 5. But that makes 10, which is a 2-digit number, and we can only have 1 digit in each place value. So what we need to do is highlight our hundreds digit as well, because if adding our tens gives us a 2-digit number, the hundreds digit also changes. So now we have 0, 5, which is just the same as 5, plus 5. So we can change these digits that we've highlighted to 10, so to 1 and 0, and leave our other digits the same. So our answer is 8,104. Now 7,383 plus 40. If we highlight our tens digits, we have 8 plus 4, but again, that's a 2-digit number. That makes 12. So instead, like we did here, let's highlight our hundreds digit as well. That means we have 38 plus 4, which is 42. So these digits are going to change to a 4 and a 2, and our other digits will stay the same. So we get 7,423. Now 3,979 plus 50. If we highlight our tens digits, that gives us a 2-digit number. But then, if we highlight our hundreds digit as well, that gives us a 3-digit number, and we only have 2 digits highlighted. 97 plus 5 is 103, but we've only highlighted 2 digits. So we need to highlight our thousands digit as well. And you can either circle like I've done here, or you might want to highlight by underlining. But really, we need to work out 397 plus 5. That's 402. So you can see that in our answer, the digits that we've highlighted change to a 4, 0 and 2. And then, as always when we're adding tens, the ones digit stays the same. Now 2,996 plus 70. Again, we need to highlight not just our tens digit, but our hundreds and our thousands digit as well. 299 plus 7 is 306, so we have that in our answer, followed by the ones digit that stays the same. Now let's show base 10 blocks so we can see why this method works for the questions that we've done. So for our first question, we started with 8,054, so that's 8 thousands, no hundreds, 5 tens and 4 ones. We were adding 50, so that's 5 tens. We can add 1, 2, 3, 4, 5 tens, but doing that means that we now have 10 tens, and we can exchange those 10 tens for 1 extra 100. So now we have 100 and 0 tens in our answer. Or, showing the same question using place value counters, we start with 8,054, but if we add 5 tens, because we now have 10 tens, we exchange those for 100, and again, that's why we have 100 and 0 tens in our answer, 0 tens even though we were adding tens. For our next question, we started with 7,383. We were adding 40, so that's 4 tens. We can add 1, 2 tens, then exchange, then add 3, 4 tens, so that's why in our answer we get 4 hundreds, because we've made this 100 here by exchanging, and we now have 2 tens. Or with place value counters, we started with 8 tens, we added 1, 2, then we exchanged, then added 3, 4. So you can see why it's the hundreds digit as well as the tens digit that has changed in our answer. Then 3,979. We can add 1, 2, 3 tens, exchange, exchange again because 10 hundreds make 1 extra thousand, and then we can add our fourth and fifth 10 so that we've added 5 tens altogether. Now you can see that we've made an extra 1,000. We now don't have any hundreds because we exchanged those for the extra 1,000, and we have 2 tens. Or using place value counters, we can start with 3 thousands, 9 hundreds, 7 tens, and 9 ones, and we're adding 5 tens, so we can add 1, 2, 3, exchange, exchange again, and then add our fourth and fifth 10. So that leaves us with 4 thousands, no hundreds, 2 tens, and of course we still have our 9 ones. Then we had 2,996, so there's 2 thousands, 9 hundreds, 9 tens, and 6 ones, and we were adding 70, so 7 tens. But if we add just 1 10, that means that we have 10 tens, so we exchange. But now we have 10 hundreds, so we exchange those for 1 more 1,000. So remember, that was just adding 1 10, and we need to add 7. So if we add another 6 tens, that means that we've added 7 tens altogether to give us 3,066, because we've got 3 thousands now that we've exchanged, no hundreds, 6 tens, and we still have our 6 ones. Or, using place value counters, you can see that adding just 1 10 means that we have 10 tens which we can exchange for 100, but doing that means we exchange 10 hundreds for 1 extra 1,000. And that was adding just 1 10, so if we add another 6, you can see that we now have 3 thousands, no hundreds, 6 tens, and 6 ones, so that's why our answer is 3,066. That's why adding tens can sometimes cause not just the tens digit, but the hundreds and even the thousands digit to change as well.